Well, hello, Felix. How are you?
Hello, I'm good, thank you. How are you?
Doing well, thank you. And I so appreciate you taking the time to come on and chat with us today. We
Yeah.
are talking with Dr. Felix Chan, and welcome to Rare Awareness Radio. You are the assistant professor in pharmacology at the School of Pharmacy in Birmingham, United Kingdom, the College of Medicine and Health. That's really cool. I
Yeah.
did some work in Birmingham back in 2008, 2009, so a little familiar with the NHS and with
Yeah.
some of the hospitals that you have in Birmingham. So it's a pleasure to meet you in person, and thanks to Adam from CRELD1 Warriors for introducing us.
Yes, thank you so much. It's a pleasure to come on board and speak with you about our work here. Yeah, very excited.
Awesome, awesome. I'm excited to hear about it. Before we jump into the work that you're doing, Felix, at University of Birmingham, and specifically what you're doing around CRELD1, maybe give us a quick bio sketch of yourself. You mentioned off air that you used to work in Providence, and I'm in Boston. I'm not far away from that area, so I'm curious to how you navigated your way to where you are today.
Yes, yeah, of course. So, I'm originally actually from Indonesia,
Oh,
so
cool.
a country in Southeast Asia. We're
Yeah,
popular for our beaches, Bali,
Bali. Yeah, yeah.
and our food, our spicy foods. Yeah, and somehow in my education, I managed to come all the way to United Kingdom, where I
Okay.
did my PhD in Newcastle University,
Oh,
and
cool.
that's where I started my first research in epilepsy. So
Mm.
I did my PhD on a specific form of epilepsy called
Hmm.
mitochondrial epilepsy,
Hmm.
which is epilepsy found in rare genetic conditions called mitochondrial disease.
Mm.
And we were actually the team that developed the first ever brain slice model for mitochondrial
Wow.
epilepsy.
Wow, that's
So
exciting.
quite
Yeah.
a breakthrough at the
Yeah.
time.
Huge.
And yeah, so kind of that solidified my interest in epilepsy and meeting patients with rare genetic conditions and
Mm.
how badly affected they can be by their epilepsies. It really still keep me interested in doing my research up to
Yeah.
this day.
Sure.
Um, so I then did my postdoctoral training at Brown University, as I mentioned with you. So continuing my work on epilepsy, but focusing more on childhood epilepsy at
Okay.
Brown.
Okay.
So again, in rare genetic conditions, in structural conditions like
Mm.
focal cortical dysplasia. So we did quite a few fundamental genetic work there at Brown University.
Mm.
And then I decided to move back to the United Kingdom to take up my independent faculty position, firstly at Aston University in
Okay.
Birmingham,
Yep.
where I was for 2 years, and then since last year I've moved over to University of Birmingham.
Wow, that's quite a journey. Indonesia to the UK to the US, back to the UK. That's pretty
Yeah,
cool. Yeah, you've definitely
yeah,
traveled. That's amazing.
yes, yeah. I've been all over.
Yeah.
Yeah,
I'm sure you've made some tremendous contacts and friends along the way. That's amazing.
yes, yeah. But through my travels, I actually come to appreciate that science is a global
Mm.
collaborative effort. So,
Yeah.
I still work with colleagues in the United States and Europe, and especially in the rare disease world, you
Yeah.
really have to collaborate and kind of share resources, share expertise, because that's really the only way we can move the field forward. So,
It's so
yeah.
interesting what you say about that too, because and I'm not a geneticist, I'm not a researcher, but I do know that sometimes researchers or geneticists they have this tendency to not necessarily share what they're doing, right? Because it's proprietary or they feel like but in the rare disease community that really isn't the case, is it, Felix? Yeah.
Yeah, it
Yeah.
really is not. And we're quite fortunate. I think the researchers and the clinicians who are in the rare disease space really are conscious about the patients that they
Hmm.
work with. With CRELT1, for example, it's a condition that is ultra rare where you
Right.
only have a handful of patients all over the world. So
Mm.
there's really no way to just do a UK focus study or a US focus study because you simply don't have enough known about the condition to
Right.
make that happen. So
Right. Yeah.
uh, this is where that collaborative spirit is really quite prominent in the rare disease space, as you
Yeah.
said. And it's something I champion as well in kind of leading my research group here at the
Yeah.
university.
You mentioned that when you came to the US, you started to kind of uh, change your focus or your interest in pediatric epilepsy, and you mentioned mitochondrial. What initially kind of drew you into researching CRELD1? Was it because you had started to shift more into pediatric epilepsy research? I'm curious as to how you made the move into and your interest in researching CRELD1.
Right. So my interest in CRELD1 actually came from meeting Adam. So in the UK, we have this
Awesome.
network that is starting to be established called the UK Rare Epilepsy Together, or
Mm,
UK Red Network.
hmm
And Adam at the time was part of the network. So there was an event held together with Genomics England,
mm,
revolving around genomics and its application in rare epilepsies.
mm.
And I was fortunate to come there actually to represent another group called Cure DHDDS that I am also a part of.
Oh, wow.
Um, and so I met Adam for the very first time there, listened to his story, unfortunate
It's
story,
such a story. Yeah, yeah.
yeah, with Lola, who
Yeah.
sadly passed away
hmm
when already when we met.
Mm,
And when I heard Adam's story, because CRELD1's condition involves kind of the heart and also the brain and the
right.
immune system to some extent, that to me, in my scientific mind, gives some clue that there may be some metabolic origin to
Mm,
this, because as you can imagine, with the heart and the brain, they are organs that are quite crucial for our bodily function.
sure.
So
Of course.
they need a lot of energy. They need a lot of metabolic energy. So a
Mm,
lot of the food that we eat would generate energy for proper heart, brain, and immune function. So to me, the fact that patients with this condition have symptoms in the heart, in the brain, and in the immune system tells me that there could be some metabolic
yeah.
origin
Interesting.
to this
Wow.
condition.
Yeah, that's an amazing association that you made there. Can you just for a second, Felix, because some folks listening may not know the impact of CRELD on organ development. You mentioned the brain, you mentioned the heart. Can you just talk a little bit about the impact that CRELD1 has on organ development?
Yes, yeah, of course, sure. So, before I think 2022 or 2023, it was when the CRELD1 condition was first found.
Mm,
CRELD1 was known to have an impact in heart development. So,
hmm
part of its function is to kind of guide the heart development so that the heart develop properly in kind of development in the womb.
hmm
And then there's also some papers that show CRELD1 is also linked with immunity, as I said, so kind of with the proper immune function.
Wow.
But we really didn't know at the time that CRELD1 would also have a big impact on the brain.
Yeah.
And this is where when Adams and the other patients who are affected by the CRELD1 mutation manifest with quite severe epilepsy and
hmm
severe neurodevelopmental conditions,
hmm
and it begins to tie kind of the kind of principle that CRELT1 has this role in all these vital organ functions, including the brain, which I'm specifically researching at the moment.
Yeah, I was going to ask you for a moment to kind of talk a little bit about your current research, Felix, and what it is that you are focusing on right now.
Yes,
Yeah.
yeah, sure. So as I've mentioned, primarily I'm an epilepsy researcher. So I've
Right.
I've been in this field for 11 years now. So it's
Mm,
been a
wow.
while. But my primary focus at the moment is why does CRELT1 mutation lead to quite a severe form of epilepsy that we
Sure.
are seeing in the kids affected by these conditions?
Mm,
And as I mentioned, some of the kids also have symptoms with the heart. Some of them have symptoms with the immune system. So
mm,
they do get quite poorly quite often. They are hospitalized quite often. They often get infections. So at some point, we will need to integrate our knowledge across the three different organs.
right.
But at the moment, I'm focusing on the impact of CRELT1 mutation in the brain,
Mm,
because many of the kids are suffering from quite severe epilepsy that
mm,
doesn't respond to anti-epileptic medications at the
hmm
moment. So
Right.
it does seem to also be kind of the priority for the patient population at the moment.
Wow, that's amazing.
Yeah.
We recently talked to Dr. Lakani at Cedar Sinai. I know
Yes.
you're familiar with his work, a colleague of his. He actually mentioned you and your work during our conversation, Felix.
Mhm.
What's kind of the methodology that you're using through your research right now?
Yes, yeah. So Dr. Lakhani, as you mentioned, was the person who found the CRELD1 gene and
Yeah,
did kind of the fundamental work to get it to a publication state so that the condition is recognized and kind
right.
of known worldwide. And we are now taking it forward a little bit more to back to the lab basically to study how the mutation itself lead to the development of epilepsy and these
Mm,
neurodevelopmental conditions that I mentioned.
mm,
So our approach has been to take cell samples from
mm,
patients, and we
mm.
are working with Adam and the CRELD1 Warriors to organize an international study with
Wow.
Dr. Howard Goodkin
Hmm.
in Virginia,
Yep.
where we are trying to collect skin biopsies, so skin samples from these children with the mutations. And what we can do with the skin samples is we can derive a form of cell called fibroblasts.
Okay. Yep.
And when we grow these fibroblasts in the lab, they would carry the same mutation that these children have. So
Mm,
it would essentially be kind of a cell model of the condition. And what we plan to do once we have set up all these cell collection would be to study them in the lab and characterize the metabolic pattern of the cell. So whether or not there is a metabolic deficiency,
mm,
we plan to test them comprehensively for
hmm.
mitochondrial function,
Sure.
for amino acid and sugar metabolism, just that very first piece of evidence to indicate whether or not CRELD1 have this metabolic
Yeah, kind of
component
back to
I
your original
mentioned.
hypothesis of that this is rooted in metabolic function, right?
Exactly. Yes.
Yeah,
Yeah. And
very exciting.
our hope really is that once we find a mechanism
Mm,
that is involved in the disease progression, is that we can then target that mechanism to develop new therapeutics.
hmm.
So what's unique about metabolism is that you can you can approach the therapeutic development through various approach. So
Mm.
one that is not common to other mechanism is dietary approach.
Okay.
So you may have heard of ketogenic diet, for
Oh, sure. Keto.
example.
Yep. Yep.
Yeah,
Yep.
where you have a low carbohydrate and
Mm,
high fat diet, and
hmm.
they can be quite effective for
Hmm.
some form of epilepsy. But my work is trying to hone in on more specific nutrients that
Mm,
may play a role in kind of epilepsy formation,
hmm.
and we can manipulate the level of that nutrients by modifying the diet that we take. So that's kind of a treatment approach that is quite unique to my lab and how we
Mm.
approach epilepsy. But of course, we are also engaged in a drug discovery
Of
project
course.
and drug
Yeah.
repurposing project,
Yep.
where you try and find small molecules, so new drugs or existing drugs that may be used for other conditions already that we can quickly repurpose for use in epilepsy. And then thirdly, we are also engaged with gene therapy work as well,
Mm.
which, as you may know, in the rare disease space, is quite booming and
Right. Yeah.
kind of taking off quite quickly. And
Sure.
certainly, it's an approach that would work for some conditions as well.
I find it fascinating, Felix, because you're not you just so beautifully articulated there. There's this sort of metabolic nutrition, food at a molecular level hypothesis that you're looking at. But of course, you're also looking, like you said, at the pharmacological, drug discovery, drug repurposing. Plus, you're also potentially looking at gene therapy and all of the advancements that are being made in gene sequencing and whatnot. You really have to do this sort of like completely like full court press, I guess, huh? On
Yes.
these conditions. Yeah,
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 and certainly I think for rare disease particularly, that's just the way the world is,
yeah.
unfortunately, and this is where as I've said in the beginning, collaboration is the key
Sure.
forward really, because you can't be an expert in everything, right?
Right.
So you have to work with colleagues who have more expertise in some space than others, and this is where it's just been great engaging in rare disease research, kind of
Yeah.
trying to push the boundary of science and I always say it like we go where the data tells us to go.
Right.
So of course, we have hypotheses in mind, but once we carry on the research, what
Mm,
the data tells us is where we need to go with the
yeah.
technology or the methodology that we need to pursue.
That's outstanding. You mentioned how you met Adam through, I guess you said it was RET, RET, right? Is that right?
Yes,
Yeah,
UK Red.
yeah, you care RET. Do you get an opportunity to interact a lot with family and patients from where you kind of work, Felix?
Yes, so I'm quite fortunate. So UK Red since then has now formalized itself as a charity themselves,
Mm,
and they're kind of representing a patient network of around 30 members. So
nice.
I do interact with quite a few different rare epilepsy conditions through the UK Red network.
Hmm.
As I mentioned, I also am the scientific advisory board of Cure DHDDS as well as
Right.
CRELD1 Warriors.
Hmm.
So I'm more directly involved with some of these organizations, but
Mm.
in the community, I do interact as well with the wider rare epilepsy space.
How important do you think that interaction is? I mean, I think people think of researchers as you're in a lab and you're in and you're kind of heads down at your bench and doing right. But I know in the rare disease space, especially that interaction's really key, isn't it?
Yes,
Yeah.
yeah. So I'm quite fortunate actually because in the UK we are quite big on promoting what we call patient public involvement and engagement,
Yeah.
or short for PPIE.
Okay.
So it's a growing trend here where we want to interface with the patient community
Hmm.
directly, almost at the outset of research initiation.
Wow.
And I strongly believe that that really is the best way forward because
Right.
ultimately, if you don't speak with the patient community first, you may kind of spend your time, effort, and resources doing research that is not addressing the need of the
Right.
patient
Of the patient
community.
themselves. Yeah. Yeah.
I've fully integrated that into kind of my research practices. So I regularly meet our patient community. We speak and we co-design some projects
That's
together as
great.
well. And we've also kind of set up some PPIE board as well for
Mm,
interaction with my lab, where we can consult them when we need to, as the research progresses and direction may change, so
mm.
that we continue to always do research that addresses the need of the patient community.
That's amazing. I feel like I didn't know about this PPIE here that you have in the UK. We don't here in the US. It's not as I think collaborative sometimes between the researcher and the patient, right? So that's very exciting. You talked a little bit about collaboration, obviously, and within the rare disease communities, there's a lot of work that you are doing together, but Felix, if you go up a level to the sort of broader scientific community, like what can the broader scientific community do in your opinion to kind of accelerate some research in this area? Is it that they just need to pay more attention to the rare disease community, or it's hard, right, when it's such a small N, right?
Yeah,
Yeah.
yes. So I think my probably message or my pitch, I guess, to the
Yeah.
broader scientific community is that rare disease research can often lead to broader understanding of fundamental science
Mm,
mechanism
mm,
that may, kind of inform us more towards kind of the more
sure.
common diseases.
Right.
So a great example I can take is another condition I work with quite a lot in my lab is tuberous sclerosis complex, or
Okay.
TSC.
Okay.
Um, and I work with the UK charity here, the Tuberous Sclerosis Association, quite a lot as well. And in the US, the TSC Alliance. So interfacing with the patient community, as I mentioned.
Yeah.
But TSC is actually one of the first conditions found where the cause is a gene mutation in the TSC1 or TSC2 genes.
Mm,
But what's more important is that it's involved in a pathway called the mTOR pathway.
okay.
So it's short for mammalian target of rapamycin pathway,
Oof.
which is a metabolic signaling pathway. So it essentially it monitors the level of nutrients in your cell, in your body, and
Okay.
would respond to it and activate kind of various pathway in our body to kind of adjust our metabolism based on the varying level of these amino acids or
Okay.
nutrients and growth factors. Uh, yeah, so the disease and the pathway was found in a rare condition,
Mm.
but we subsequently find that mTOR pathway is actually involved very importantly in cancer.
Oh, wow. So
Uh,
it does have an impact on the
yeah,
broader. Yeah.
and
Yeah.
it subsequently was found to be important as well in neurodegenerative conditions
Hmm.
like Alzheimer's, dementia, and more recently, it's now found to be involved in aging as well. So a
Wow.
lot of kind of our longevity study, our anti-aging approach has now focused on modulating the mTOR pathway.
Wow.
So I guess in a sense, we have a track record of
Yeah.
rare disease research and kind of rare genetic research leading to fundamental biology understanding that is then vital for many other
Yeah. I mean,
conditions
certainly
and many
just that
other
example that
processes.
you just gave really kind of points to that. Yeah.
Yeah.
Felix, you mentioned that you are on a couple of different scientific advisory boards. Obviously, very much involved with CRELD1 Warriors. What other sort of advocacy work are you personally doing, or are there certain advocacy organizations that you're paying really close attention to?
Yeah, so aside from kind of the scientific advisory board capacity that I do,
Mm.
I'm also quite heavily involved in advocacy for rare disease
Oh,
here in the UK.
mhm.
So I was very fortunate to be invited as part of Project Pearl last year to raise awareness in the parliament, where we kind of
Outstanding.
educate our parliamentary policymakers on
Yeah.
mitochondrial disease and the importance of rare disease research.
Mm.
So it's something that I'm very much aware of as well. That rare disease research, we need to work with our policymakers as
Yeah.
well to kind of enable rare disease research. And as new treatments come and be developed as well, we need a mechanism to enable these treatments to make it into the patients as well. And that involves working together with our colleagues at kind of NICE and the people who make the guidelines so that they can be implemented in the NHS and accessible to patients in the UK.
That's outstanding. And advocacy work, it's just so important, right? And the public awareness that you just mentioned, right? Your parliamentarian sort of getting them to understand from a policy making standpoint, right?
Yes.
That's amazing.
Yeah.
Felix, before we let you go, I'll ask you a question that's, probably a little hard to answer. But there's so many complexities here with the work that you're doing around rare diseases, especially CRELD1, its related conditions. What is just motivating you to keep pushing forward every day, Felix?
Yeah, it's a good question. So, as I mentioned, so I had a very, very fundamental moment back in my PhD
Yeah,
where I met a family with of a caring for a child with mitochondrial epilepsy,
yeah.
and the child was actually in a wheelchair and kind of
Mm,
not able to speak or function too much, and they were on a tour of our facility. And as soon as they heard that I was studying epilepsy, they kind of just immediately light up and said, "Oh my God, the epilepsy is affecting, my daughter's condition a lot." And they asked a lot of questions, and I continue to meet parents of children affected by these rare epilepsy, like
yeah,
Adam and other family members that I work with, and I continue to just be inspired by them. Really,
yeah.
I can't imagine kind of picking the lottery of having a child that is
Yeah,
diagnosed with a rare conditions, let
sure,
alone something with epilepsy, where there is actually a chance of having sudden death from epilepsy as
sure.
well. So
Especially as an infant. Yeah, yeah,
yeah, so
absolutely. Yeah.
it's really not an easy condition to live with.
Mm,
And when you have just some of them can have seizures for up to 24 hours at a time.
mm,
Some of them have seizures all their life.
mm.
Like it's just such a difficult condition. And I'm always in the mindset of like, what can I do to make
Yeah.
the world a better place? And I feel like this is the role that I've kind of been fortunate to be a part of, and that's what keeps me going basically every day.
I can feel it. I can feel your dedication and like you said, that sort of aha moment that you had. And I can feel how important it is for you to interact with patients and see the impact that potentially the work that you're doing is having on improving the lives of those patients, of their moms and dads, of their extended family. So thank you, Felix. Thank you for doing that work. I appreciate it.
You're welcome.
Yeah.
Thank you.
Yeah, you're very welcome. So we've been talking with Dr. Felix Chan from the School of Pharmacy and the School of Health Sciences at the College of Medicine and Health at the University of Birmingham. That's a lot to say, but thank you so much for your time, and we look forward to speaking again with you soon.
Thank you. Thank you for having me.